I would like to move to the presentation to Mr. Henry. So I'm sure you got the points highlighted by Mr. Richard in this presentation when he talked about building digital resilience and what companies should do to achieve it, and also the point that Mr. Fajar talked about various strategies in building digital resilience. Now, maybe you can add more perspective on this topic, Mr. Henry. Therefore, the floor is yours.
All right. Thank you very much, Pak Vishnu. Let me share my screen. So are you able to see my screen?
Yes.
All right. So okay. Thank you very much. So in adding on to what Pak Richard and what let me see.
Fajar.
Fajar was sharing. Sorry about that. I missed the name itself. So what I'm going to do today here for the audience is to share a little bit on how we get to where we are today. So we talk about infrastructure, we talk about cloud, but where do we get to from itself? So I'll talk a little bit about the IT evolution in terms of how things are getting to what we are today. And before I move into building a resilience business and business continuity. So a little bit history for those that are online here. Way back in the 1960s, IBM brought to the world its first modern mainframe, the IBM 360. That signals the time where mainframes started going mainstream. The capability of that allowed batches of applications to be ran and thousands of remote terminals to be able to connect to through the proprietary communication protocols and data lines. And then we evolved into the launch of the PC era. So in the PC era, we see that the companies, IBM, same things about IBM itself, they launched the first personal computer called the PC, which then uses the operating system from a then later known company called Microsoft. And it went on to democratize computing and launch many of the standards that have since come to define desktop computing. By the 80s, there was an increase for the need for businesses to connect all their standalone PCs so that employees could collaborate and share resources. The client-server model is born, and it offers a way to enable a truly distributed computing with PCs. On top of that, we move on and we move into virtualization. So for those who are not familiar with virtualization, it actually goes way back to the 1960s. Back then, the concept was largely unremarked for nearly 2 decades with the rise of the client-server model. VMware then revived that concept, apply it to the x86 machines, and they launched it as the virtualization for the customers to use it. So virtualization of infrastructure contributes greatly to reducing downtimes, reducing costs, increasing efficiency and productivity, which in turn lays the foundation for cloud computing. So cloud computing gives enterprise IT on-demand access to computing resources, including networks, including servers, storage, applications, and services, without the cost or hassle of managing and maintaining all that hardware. There's also an additional benefits to cloud services. Cost. The pay-as-you-go models means that businesses are charged only for the resources that they have consumed. Most importantly, cloud services can scale vertically and horizontally, eliminating all headaches associated with optimizing on-premise solutions for under or over utilization. So now we look at the present, where we are having cloud platforms offering infrastructure as a service, the software as a service, platform as a service. We are moving into an era with everything as a service. So if you look into the right places, or depending on your mindset, the wrong places in the internet, you could even get ransomware as a service, DDoS as a service. So we are moving into a world where consumers, customers consume services as a service instead of running it as a services hosted in their own environment. And that is all due to the emergence of cloud. Speaking about cloud, over the past decade or so, the word cloud has taken on a new meaning to many people. Rather than a visible mass of condensed water vapor floating in the skies, the cloud has taken to the IT industry in the form of data. We have private clouds, we have public clouds, we have hybrid clouds, community clouds. What do all this mean and where did they come from, if not from Mother Nature? On a bare-bone level, a cloud refers to a large pool of compute and storage resources that can be accessed by individual through a portal of some sorts, whether it's be the internet, an application on the phone, through some other means of access. People can retrieve their data pretty much from everywhere. So with public cloud providers such as AWS, Azure, Google, and so forth, consumers, businesses are able to avoid paying for physical infrastructure on site and rent spaces in the cloud. Cloud computing is changing the game for IT in many ways, both good and bad. We started out on premise in our private data centers. We are in control of our users, our applications, and our networks in a walled garden of services. Then we introduced the concept of private clouds in order to enjoy the functionality where we can spin out additional services on demand, lower the recovery time of an outages, increase the flexibilities. So these are all functionalities that you get to enjoy with a private cloud itself. Next, we introduce public cloud services to the mix. So this includes popular vendors like AWS, Microsoft Azure, and there are times and situations whereby we're not able to fully migrate out to public cloud due to compliances, due to securities, due to policies, and whichever. So then the concept of hybrid cloud is introduced, where customers deploy applications or services that span their own data centers and at least public cloud itself. This allows customers to enjoy the flexibility of fronting the applications to the user where they are accessing it from and remains the control over applications that they deem to have high security requirement. So this stays within the data center and allows much more flexibility deployment of the infrastructure itself. Lastly, we introduced multi-cloud, which allow customers to either duplicate services across the cloud or spread services across the cloud by the best fit for a particular use cases itself. Looking at multi-cloud or distributed cloud itself, is used to meet compliance needs, is used to meet performance requirements, is used to meet the SLA requirement of the customers. It is a centralized managed from a single portal itself with multiple instances of services running in multiple locations itself. So you could have a customers or a services that's running in the public multi-cloud itself. Customers from perhaps in the US regions, they wanted to access to an instance that's running in US for better performance. You have customers that's running locally in perhaps Indonesia. You wanted them to access to the information in local Indonesia cloud. So that will allow you to comply to multiple compliances. Performance is one. Secondly, in terms of compliances, certainly data are not allowed to leave the countries for more stringent security aspect of things. Then multi-cloud deployment will allow you to comply to that. There's benefits of having multi-cloud is you increase compliances, you increase uptime. Should there be a failure in one of the instances, you are able to recover it much faster than having appliances on site where you need to wait for the potential RMA. Then scalability, like mentioned earlier, clouds you can scale out vertically, horizontally, and with the incorporation of the automation solutions, you can scale out on demand and scale down on demand itself. When there's a boom in the requirement, in the demand, you scale up additional resources based on the monitoring of the load that's coming in. When there's a lesser demand requirement, you scale down as per what is needed. And of course, the processing is faster because you're leveraging the compute of multiple systems for a given task, and as well as you have the standardization of all the configuration across the multi-cloud itself. And that brings us back to the question that what we are here to discuss for. How do you utilize the current IT landscape to build resiliency and business continuity into your businesses? When we're looking at building resiliency, we're looking at building business continuity. One particular terms that always comes up to people's mind is, do I need load balancing? If yes, why do I need load balancing? So load balancing, in certain contexts, you have a server running services that your client is accessing to. One big question to answer why you need load balancing is that the servers by itself are not big enough. Even if you employ supercomputers, one single server is not sufficient enough to handle the ever-growing load of the client accessing to the services. So in peacetime, when you first started, yes, this is fine. Users are coming to my web servers. Everything is good. I'm happy. My business has grown. And I have multiple users accessing to the services. With large enough user base coming in, my server will gradually hit the limit itself. And you will need to introduce multiple servers in this aspect itself. And that's where load balancing comes into play. And the second reason why we are looking at load balancing in the building of resiliency is things breaks. You have your web servers in peacetime, everybody accessing to it, everybody's happy, I'm the king of the world, everybody is fine with that. Like what you see in the picture here, Titanic vow as the ship that never sinks, breaks, and it sinks. This goes the same with your application itself. It's not a matter of if it will break, it's a matter of when it will break. And when things break, you want to be able to direct your user to the remaining server that is alive and healthy. So that is where a load balancing will come into play, especially importance in building resiliency and business continuity. Some benefits that you get to enjoy with load balancing is scalability. When you have reached the max of the capacity of what your current application instance is capable of providing, load balancer allows you to scale up easily without the need to modify any of the codes. And it's also allowing you to scale down should there be a need that you are decommissioning your services. This doesn't impact any of the users, and it allows you to do it with simplicity and agility. Availability, one big part of building resiliency is to ensure that your application to your users are available at all times. And load balancer help ensures that by creating the health monitoring best suited for their applications. And whenever there's a server instances that's down, load balancer will take it out of the load balancing pool and direct the users to those that are healthy. And last but not least, agility. It allows you to move things fast in today's IT world. Agility is a key in keeping up with the competitions in the IT industry. You will want to be able to deploy your application out to the user, react to potential security issues that happens, and that's what a load balancer is here to help for. You might have another question in your mind that, so if I go to cloud, do I still need to employ load balancing or not? We talk about multi-cloud, we talk about private cloud. So you may be wondering why we are still talking about load balancing in a cloud-focused world. Are services that are built into the cloud not auto load balance or auto everything? The simple answer is no. Building a set of virtual machines in the cloud as web server doesn't automatically load balance them in any way, just as building them on-premise doesn't. Load balancing in the cloud enables some of the wonderful benefits in the clouds, like auto-scaling that we've talked about, elasticity on demand. However, you still need to plan that out and build that out. You might be wondering about the effectiveness of cloud native or cloud delivered load balancers for the likes of AWS Azure. So this offering certainly provides a lot of convenience and are a nice choice if you're simply deploying a single application and only ever wants to commit to one public cloud provider. Native load balancers from cloud provides and offers simplicity of deployment, but it doesn't offer the maturity of features that, excuse me, that a dedicated load balancing appliances does, especially when we start moving towards multi-cloud scenario. How do you manage the consistency of the configuration across different cloud provider? You have the policy of configuring certain assets for example, Azure. You have a system deployed in Azure and an identical system deployed in AWS. That will give you the ultimate failover between cloud vendors. But if you're looking at the load balancing standardization across the cloud itself, you will not be able to standardize it 100% across both providers. And the only way of looking at taking advantage of the geographies of the global services is to utilize global server load balancer. And one vendor may not have their coverage in that extent. Microsoft Azure might have the global presence of certain regions in the globe. The AWS might cover the geographies where Azure is not present. You need some intelligence to publish your applications in the scenario so that your users will be directed to the right location under the right circumstances. This solution isn't for free. Multi-cloud does comes with extra management overhead to build and to keep the solution in place. This is where standardizing on a load balancer solution or uses services that can manage your load balancer needs irrespective of platforms. It can save you a world of pain. Standardization offers the ability to train your administrator and developer once, irrespective of what multi-cloud services they are utilizing, and as well as to take advantage of non-native capability offered by a vendor without introducing additional management overhead. The goals of performing load balancing in multi-cloud, what we look for is essentially key features and benefits to make the implementation and operation of the network easier. We want the technology to be simple enough to deploy across multiple clouds. The solution needs to be available in the cloud provider marketplace or as a BYOL image that you can easily deploy into the different cloud itself. Secondly, the license should be flexible, easy to consume, permanent license, subscription license, pay-as-you-go license, or even consumption-based licensing. It makes the use of load balancer technologies easier to procure and manage. And of course, next, we need to ensure that we're getting the features we expect from a mature technology like load balancer. Capabilities like advanced layer 7 health check, least connection algorithm, they are the table stakes for selecting a load balancing technology. All these technologies should be available at a competitive price for optimum value. The cost of load balancing technology should be weighed into the decision. Do not assume that the native load balancing options in the cloud are less expensive. The annual calculation of native load balancing solution is always, if not, is almost, if not always, more expensive than the load balancing solution by a factor of up to 7 times. Finally, look for a solution that is consistent across all different clouds and network, and load balancing technology should work the same no matter where it resides in terms of users interface, configuration, operational supports. a single support infrastructure for all load balancer, it makes sense for multi-cloud deployment. One of the last slides that I want to move is to talk about some common mistakes that businesses approach when they are moving to cloud, because many businesses approach the thought of going to cloud focusing on saving money. They believe that renting services or renting infrastructure or renting platforms will reduce the total cost of ownership and the total cost of management of their IT infrastructure. In many cases, there is not a cost saving by utilizing cloud. If you calculate the spending for on-premise, private cloud, or public cloud utilization, there is definitely flexibility gain. We gain agility, we gain elasticity that everybody wants in their applications network environment. Moving application to the cloud is not as simple as copy and paste the application from your data center into a server in the cloud. There are inherent difference on how the cloud works and how it is managed. That makes it important to understand the application flow through the front end, the middle, and the back end, as well as a very important factor of things, how the security policy and the privacy policy works in terms of the application and its data. There will be some control that you need to give up on when you move to cloud. You're not going to be able to make AWS on Azure bend to what your security policy requires. It's a matter of whether you can modify your security policy in order to be going on to the cloud infrastructure itself. However, the agility and elasticity we expect from cloud, this also requires effort. It's not automated. Centralized orchestration tools, automation tools, the likes of Kubernetes, the likes of Ansible, the likes of OpenStack, they are required to analyze, manage, and provision resources based on policy and demand. This should be used in conjunction with the centralized management capability of the deployed services. Shadow IT exists because individuals diverge from the corporate standard and utilize IT options that may be convenient for a specific project or use cases. So when you move or when you decide to move to a public multi-cloud strategy itself, consolidate the potential long-term plans and create a common standard that everyone can be comfortable with and adopt. It does not make sense to have 6 projects utilizing 6 different technologies from 6 different vendors to spread across a multi-cloud architecture itself. So this is what I want to share regarding some common mistakes that businesses make when they move toward clouds itself. And with that, I come to the end of my presentation. Thank you very much, everyone, for your attention.
Okay, thank you, Mr. Randy, for Mr. Henry for the presentation. I think you nailed it when you said that everybody thinks that everything going smooth, but something break, and we lost the connection, we lost the server, and suddenly we have a trouble with delivering services to our customers. Thank you, Mr. Henry, for your presentation. So